In this video, we're gonna continue the topic of parabolas. Y equals x squared is our basic shape, basic parabola, and our standard form of the parabola is a times x minus h squared plus k. So for this, to obtain this shape, a must be equal to 1, h and k must be equal to 0. We're going to treat any other parabolas as transformations of this one. Okay, so for example, we have this parabola right here. It has a slightly different equation, but as you can see, the shape of this parabola is the same, but it's shifted. So its vertex, it was shifted 2 units to the left and 1 unit down. So that will tell you that h equals 2 and k equals -1. So for this formula, you're going to have, we have to still identify a, but I can tell that it is a 1, and I'll tell you how I can tell that later. So we have x minus 2 squared minus 1. So see, h is positive, so because we have a negative in the formula, this transpires here, and that is why it's moved in the left direction. Okay, for the k, it's straightforward. If k is negative, parabola moves down. If k is positive, parabola moves up. Now, how did they get that equation? Well, if you were to expand this formula, we're going to have x squared minus 2 times x, so that's 4x, plus 2 squared, 4, and minus 3, and that will give you um, the other form of the equation. I mean, minus 1. I'm sorry, guys. I'm thinking and writing at the same time, and sometimes I think ahead of myself. So this form is called a general form of the equation, and that's how you go from the standard form to general form.
Here's our next example. Write an equation of the function given its graph. And there are actually two different ways to find that equation, and I'm going to show you both right now. The first step for both methods would be to find h and k first. So basically look at the vertex, and when you read the graph, you will figure out that h is -2 and k is -3. So h is -2 and k is -3. So what we also need, we need a in order, so because let's recall that our standard form is a times x minus h squared plus k. So in order to write this equation, we need hk and a. Okay, so we already know h and k, and we can substitute it in. But now how do we figure out a? That's where the two different methods come in. So the first method is just to eyeball it. Okay, so it's based on the fact that when you look at the standard parabola with a equals 1, then if you go from the vertex, if you go 1 unit to the right, it's going to be 1 unit up to get back um, onto the parabola. Okay, so 1 to the right, 1 up. So if you go 2 out, now it's 4 up. So it's not going to be consistent for the entire parabola everywhere. But if you start with the vertex and go one to the right, one up, it should be like for the standard parabola. For when a equals 1, it's 1 over 1 up. Now, for this one, if you look at it closely, then it's not 1 out, 1 up. It's 1 out and about zero point 0.5 or 1/2 up. So by eyeballing, I would say that A is 1/2. And it is. But so I would write my equation as f of x equals 1/2 x minus a negative 2 will give me plus 2 squared and then minus 3. But what if, and it works well when your a is actually a whole number, when your h and k are whole numbers, and then you can count the steps over and up. But what if it's not a nice number? Let's say it's, I don't know, 5/7. Would you have eyeballed it on, this graph this small? It's very difficult. So therefore, we're going to have an algebraic way to do it, which is going to be more accurate, and it works in all situations. So we already figured out our h and k. And what I'm going to do, I'm going to rewrite this equation with our h and k already in place. Okay, so the equation is f of x equals a x plus 2 squared minus 3. Okay, so again, I want to find a. In order to find a, you need to choose a point on the graph that's kind of easy to read. So for example, it could be 2, 5. I think this is the exact point. Also, there is a 0, -1. You can choose any point. So let's choose this one, 0, -1. The only point that it cannot be is the vertex, because we already used the vertex. It's in there, and you're going to get an identity when you plug in that point again. So it has to be any point on the parabola, easy to read, but not the vertex. Okay, so let's actually plug in the values. So this tells me x is 0, and this tells me y is -1. So f of x is y. So I'm going to plug in -1 there. A, and then x is 0 plus 2 squared minus 3. So what I'm going to do, I'm going to add 3 to both sides and square my 2, multiply by a and simplify. I get 2 equals 4a, and dividing both sides by 4, I get 2/4 or 1/2. So now I can go back and plug it into the equation and get the final form. 1/2 a x plus 2 squared minus 3. What? Sorry. No a. Just we get f of x equals 1/2 times x plus 2 squared minus 3. Now, and that's the standard form of our equation. What if you wanted to write not the standard, but the general form? How would you transform it into a general form? Well, it turns out it's very easy. You have to basically open up the square So you have x squared plus 4x plus 4. Distribute the 1/2. 1/2 x squared plus 2x plus 2 minus 3. And combine 2 and negative 3. And we're done. So both of these two forms are interchangeable, and in the next video I'm going to show you how to actually go backwards from this form into standard form, from general to standard form. But for this video, I still have one assignment for you, and it is to try and write an equation for this problem. It says a coordinate grid has been superimposed over the quadratic path of a basketball. Find an equation for the path of the ball. Does the shooter make the basket? Okay, I'm gonna zoom in a little bit into the picture so you could see it better. Here it is. So we have the grid here, x, this is y and x. So where the first, where the ball takes off is actually 0, 0. So here's the vertex. Can you write an equation of this, of the path? Try it, and I'll see you in the next video.